Thank you, everyone. As Maribel said, I have spent a lot of time studying blockchain, and why that's important to digital transformation is what's really interesting is, we've been hearing about driving our businesses forward, but there are so many shiny objects in the world, right? There are so many emerging technologies that we could use, but are they the right ones and for us to spend time on? And so Maribel and I have worked together. I've spent a lot of time in services, consulting, and systems integration, studying emerging technologies, but I do a lot of product management, and my background is actually in sourcing. So I feel like I'm in a lot of the same situations you are, which is, part of me is like, that's really cool. Let's go build something awesome with this. And then part of me says, how are we going to pay for that? And how much money is that worth? Because I spent a lot of time in sourcing, so those are the questions that sourcing people ask. So that's actually perfect for where we are in blockchain, because that's exactly the questions that we should be asking ourselves. So how many of you have read at least one article on blockchain? Yeah, okay. So by now, you know that blockchain cures cancer, picks winning lottery numbers, is about 2 months away from finding extraterrestrial life, right? Now, if those are in fact the kinds of business problems that you're solving, there are actually better technologies to do that than blockchain, right? Because blockchain does some really cool things, but it's not always the best technology, right? And in fact, someone said to me a few weeks ago that the way that you know somebody understands blockchain and how it works is because they will spend most of their time telling you why you don't need one. It's a very specific kind of a technology. I'm going to talk a little bit about it. But having said that, it does have some very cool applications that really will help you not just do things differently, but to do things that you couldn't do before as an organization. And that's why I'm really excited to talk about digital identity on a blockchain, because I think that it will help us do things as organizations and as markets and as economies that we can't do with non-blockchain technologies. So let's actually start with the definition of what's a digital identity, right? Because I mean, that would be the basic thing. What are we actually trying to accomplish here? So your digital identity actually has a lot of pieces. So the data that's created and collected about us online, or maybe it's created offline, but we put it online, right? So think about things like your social security number, tax IDs, your credit score. There are a lot of things about you that are online somewhere, and that's part of your digital identity. Digital identity is also how systems know who we are, right? Your PIN at the ATM tells your bank that you can take that money out because it's your money, because your PIN says that that's you, right? Like Joe was talking yesterday about Netflix, and Netflix, which is my husband's account, knows that it's him until he goes away for a couple of weeks, and then Christine does the Jet Li marathon, and John comes back, and why are all my recommendations in Chinese now? So Netflix thinks that John all of a sudden went through some transformation now. But that's the way systems work, right? Because from a security standpoint, right, that's what we talk about when we talk about access management, right? Why is this user behaving differently than they were before, right? It's all about making sure that there's some kind of pattern to the way that the person's behaving. So the way that you behave online and the way that systems know who you are, that's part of your digital identity. The brand, the reputation, the expectations that people have of you based on things that you create online, right? I mean, think about if you've ever gotten into a flame war, wrote a nasty Yelp review, said something, got into a political discussion. All of those things that are captured online are also part of your digital identity in one way or another. Plus, there are all the legal aspects of your identity, right? When you check I agree to, a SaaS application, legally, yes, that's you. You clicked I agree. Legally, that accepts you as you've done work online. So all of these different interactions that we have are all considered part of our digital identity. I should also say that an identity can be you as an individual, can also be you as a corporate entity, maybe a nonprofit organization, but some entity that's not an individual, or it could be a device, right? In an IoT world, you need to know that the identity of a device, is it a toaster? Is it a washing machine? Is it a smartphone? Is it a car? What exactly is this device that is being used, and who owns that? That's part of your digital identity also. Okay, so if that's the identity, What's a blockchain? Someone told me at dinner they were excited to hear this presentation because they asked one of their colleagues what a blockchain was, and the colleague wouldn't tell them. They said, too complicated, I don't have time. So I'm going to try and answer that, but I also don't have time. Hi, Carl, right there. We're outing you now, Daniel. Now you're going to have to explain it later. But you got a long flight home, so you'll have time. So, blockchain is a set of technologies that are designed for the transaction of digital assets, like a net native digital asset, like a Bitcoin, like a cryptocurrency, or a tokenized version of a physical asset, right, that you can transact. The data are permanent and tamper-proof. So that means once you put data on the blockchain, it's not coming off. You can't erase it, you can't undo it, it's there permanently. And it's tamper-proof at the moment. For those of you who know anything about quantum computing, everybody's starting to say, well, once we have quantum computing, then blockchains won't be tamper-proof anymore. I'll take their word for it, that's pretty far away, but we'll kind of stick with what's in front of us right now. But the point is that it would be a safer data store than some of the ways that we're storing our data right now. Given all the hacking of our data that's been happening, if we could protect our data better, that would be better for all of us. So the technologies that are included in a blockchain, I promise this is like the most technical I'm going to get through the whole presentation. There's a distributed ledger. Distributed ledgers are a form of a database where each of us has the same set of data, right? Maybe we have all of the data, maybe we have shards of the data, but each of us have a copy of the data, and that's one of the ways that we know that there aren't bad things happening, because we all know that if you change something in your database and my database doesn't match that, that's part of how we capture that. So that's the distributed ledger. There's cryptography, which is a lot of very complicated math that helps you with public-private keys. So when you're trying to do the transaction, the math that makes that happen, and that actually feeds into some of the ways that people do proofs, like what's their reason for being part of the network. And then there are consensus algorithms, which is mining and nodes, which you may have heard about. And I will happily explain to you at a point that's not now, because I only have 20 minutes. But these three things are typically what we think of. So when you hear somebody say blockchain, this is really what you should be thinking, right? Even though there are other ways that people talk about it. So a blockchain implementation could also include something you might have heard of called smart contracts. Really, a smart contract isn't a contract at all. It's automated business rules that govern the transaction. So this is the way that the system can decide whether a transaction should go through or when the transaction should go through. So very quick spin, I realize, but again, I want to talk about what you would do with a blockchain, and then if you decide the blockchain is actually something that you want to think about, we can get more into the technology. So let's talk about some examples that we have of data that we might each have been acquiring over the years. Right? So there's government-related data, right? Your passport number and your photo and where you've been, social security number, your birth certificate, land registry. There are a lot of things that the government and the federal government, state government know about you and keep track of and make sure that you should have certain rights and certain services. There's a lot of records online that are financial, right? Mortgages, credit history, etc. Maybe you were born in another country, maybe you work in another country, and another government has data on you too. Maybe you're entitled to a pension someplace else. Maybe there are some other work visas that exist on you in other countries. There's your social identity that we talked about, right? So these are all the different interactions that you've had online that are associated with you. There are health records and insurance records about you online, right? I'm going to guess that most of you don't have copies of x-rays, right? Surgical records, right? Those are all things that other people have about you, right? You have to go to the hospital or go to the doctor if you wanted a copy of those because you don't have them. And then your brand identity. So as we think about our work, right, again, as entities, but also as individuals, right, there's going to be a videotape of this presentation. Might be on YouTube. So your work history, any consulting that you've done, digital rights management, right, in terms of how do we know that that's actually your presentation and not somebody else's presentation. All of these things are part of the digital identity. Now, the tricky part in today's world is that most of that stuff is not controlled by us. So what blockchain-based identity would do for us is that it allows us to collect, store, control, and share, and validate our own identities in a way that's not possible. So if you study the space a little bit longer, the term is called self-sovereign identity. So you have more personal control over your data. How do you do that? We can more proactively decide who can see our data. So again, think about the medical records. You have to ask somebody else to give those to you, even though they're about you. If you had a store of that data somewhere, and then you change doctors, instead of calling your old doctor and say, hey, I need you to ship my records, you can give them your private key, and then they would be able to go and see that, and you'd cut out the middleman that way. You could reduce friction in your business transactions because you can improve the speed and accuracy of identity-based processes and hopefully secure it better. So a good example is if you want to apply for a mortgage and the bank says, let me see your tax records, they still actually validate that with the IRS, right? But if you had a token on a blockchain that was the validated IRS certification that said, yes, we got this person's tax records, here's the electronic certification, right? So the bank wouldn't have a copy of your tax records. What they would have is a copy of the certification that the IRS gives them that says, yes, I can validate that the information that the person gave you is correct, and that exists. Now, because of that, you might be more willing to participate in digital transactions. So in this whole environment of digital transformation, you may be more willing to do transactions online and different kinds of transactions because you're more secure in your own data and you're only giving the parts of the data away that you need to, right? So you're an employee at a new company, and really all your company needs to know about you, let's say, are you 18? Are you legally able to work in the United States? And do you have a valid ID that we can validate that you are who you say you are? So on a blockchain, they may be able to validate all of that. So you don't have to give them your birthday. There's just a certification that you ping and says, is this person over 18? Yes. And here's the certification that they can keep track of that. So you'd be more willing to do transactions because you'd have better control over your data. And government services could get delivered faster and more accurately. This actually something, here in the United States isn't too much of a problem because we do have, social security numbers and such. But there's a program called ID4D, which is the World Bank, the UN, UNICEF, and some other organizations that in other parts of the world where people don't have a good way to prove their identity, they can't get services, right? So the more that you can actually create a way for people to validate who they are, the more that you open up the market and allow people to have access to things that they should have. And then more reputational control over your own identity, because again, this is all about control and your ability to show other people what you want and don't want. So if you think about something like the GDPR regulation and the right to be forgotten, you don't have to worry about whether something is on somebody else's server and whether somebody can erase it or whether you want them to erase it, because it's sitting with you, and then you just shut off access to that. So if you don't want something to be seen anymore, you closed your bank account, and now you don't want them to have your personal identifying information, then you shut off their access because the data is not on their system, the data is someplace else. So that's actually for us as individuals, and all of those things actually apply to us as part of the entities that we belong to, but there are actually some other benefits, right? So as a company, you can protect yourself and have more control over your own data, but it actually allows you to do some other things, particularly as you think about your own customer data and how you protect customer data, right? You'd have lower costs from administrative errors and rework. Someone told me the other day that 25% of healthcare costs come from the rework of administrative mistakes. Somebody gets their insurance claim denied because the doctor typed in their name wrong and the records don't match up, right? And then you have to go back and find it and do it that way. So if you're doing a lot of this on a blockchain with identities that are validated, a lot of that rework of entering things in over and over again, transposing numbers so that your social security number is showing up wrong somewhere, all those things go away. You have more confidence in identity governance and access management. So most access management systems, again, as we mentioned earlier, start with the idea of you've been onboarded now because I know that Steve works in finance, Steve gets access to these sets of systems. But if you could actually go further back and say, now I know that when HR onboarded Steve, they actually did all of the correct validations, right? So I have better confidence that the systems that he has access to are correct, and that identity is reusable. So if Steve stops working here and goes working there, goes to another company, a lot of the data about him in terms of the access management actually can follow. So there's better security, not just from data protection, but also the way that people interact and how we come to know who they are. Faster time to revenue, because if you thought about that mortgage application I was talking about earlier, that process takes about 3 to 4 weeks, right, if you're waiting for the records to come back. If you could validate that within 10 minutes, think about what it would mean to get a mortgage in a week instead of a month, right? So for the customer, that's fantastic, because of course that takes a lot of stress off them. But if you were the bank, that's faster time to revenue, right? Because that interest is coming into you faster. There are a lot of opportunities like that for entities that if you could reduce the time it took to onboard a customer, reduce the amount of time it took for a customer to be working with you, that would be a great way that you could get more revenue and be more productive. And then compliance reporting costs can be reduced. So you onboarded Christine, and she said she was 18 and legally able to work in the United States. You're doing your regular compliance reporting, and somebody says, well, how do you know? What did you do? And it's like, yep, here's the record. I can tell you that on November 7th, I pinged, here's the answer, here's the cryptographic hash that shows that I asked, and here's the answer, right? Again, the hash for the answer, not the answer itself. So that you can report on your compliance efforts a lot easier. So that's like an employee example, but yesterday, someone was talking about conflict minerals, right? Joe was talking about conflict minerals and Everledger, right? So imagine, again, instead of like trying to find all these reports and running through all these papers and all these different systems, you can say, I can track something through my supply chain all the way through. So I know it's not a conflict mineral, right? Because I can show you who had it, when and where, with the timestamps, and I can prove it. So the compliance is much faster. And the cost of reporting is much faster because it's a lot easier to find the data. Okay, this is how identity works today. And it's a really ugly slide, not just because of my bad PowerPoint skills, but because it's actually an ugly process in real life, because nobody trusts you about yourself. Isn't that funny? That like, you're you, but nobody believes that you're you. So they all run around asking other people if you're you, right? And so you're kind of in the middle of this, but really everybody's working around you. The visionaries who are working on digital identity on a blockchain want the world to look like this, that you are at the center and everything goes through you, so that because it's been certified and there are data validated about you through a third party, right? So again, that IRS example, or like your passport. Let's say the next time you go to renew your passport, you also get a digital token for your passport that you can put online. So if you go somewhere and you need to prove that you're a US citizen, you can say, here's the certification that shows that I have a US passport. And they don't have to go and ask somebody else, and you don't have to run around and bring your passport with you everywhere. So the idea is that we become the center of our own identities, and we have self-sovereign identity. So as an end state, that means we want to move from a situation where lots of our information is not in our control to having direct control of our own information. In GDPR, they talk about this as the personal data store, right? So you have the direct control over it, not all these other people out in the market. We also want to move from an environment today where the information about us is spread across multiple systems that never connect, to having all of our data in either one blockchain or multiple blockchains that interconnect, so that it's a much more seamless process in terms of getting access and sharing access. Today, even if we have control over our data, a lot of institutions don't believe that version, right? And they still have to validate around us. If we had a digital certificate that could prove that we are who we say we are, then that cuts the time for everybody involved, because we don't have to keep double checking and triple checking the information that we have about each other. And there's a lot of money that's being spent validated. I'm doing a project about KYC, for example, right? Know your customer in the banking industry, right? Because if you want to sell a banking product, you have to make sure that the person is who they say they are, and also, the different institutions are. who they say they are, and the cost of validating that, $60 million, $120 million a year, there's a lot of money being spent making sure you are who you say you are. So if you can take part of that down as an entity, that helps. So what does that mean for digital transformation, right? So kind of wrapping up into all of this together, there are a few things to think about. Think about onboarding and offboarding, right? Yesterday during the DXC presentation, he talked about maybe having somebody come in to work for a day. Think about a situation where today you'd spend more time validating that person's employability and that they are who they say they are than they would spend on site. So think about a situation instead where you could validate them almost immediately and then they could start working. So a lot faster. Picture how digital identity could be combined with other things like mobile and IoT to deliver services that aren't possible today, right? You might know that it's a device, but maybe there are other things that combined with somebody's identity, you could change the kinds of services that you are offering. Consider, again, that situation of people who currently can't prove who they are, right? The UN is also doing a lot with unbanked, right? So if you could get access to people who previously were unreachable, right? Because now they've got a way to be able to work with you. Think about what that would do for you. And then dream about combining digital identity with analytics that we just heard about. Like think about something, we were joking earlier about curing cancer. It actually could. If we could anonymize health records and that you would be willing to share anonymized health records, but now we had all that data that we could do for population health management. We could really do some great things to improve global health. And then imagine that you could do good in the world through your digital transformation efforts. Think about supply chains. There's a lot of bad things in supply chains, right? Think about taking out human trafficking, right? The reason conflict minerals are a big deal is because they fund things like child soldiers, right? And so if you could take out conflict minerals, you could reduce a lot of the bad things that are happening. You could reduce counterfeiting, right? You could reduce a lot of illegal activities in the world just by doing your own digital transformation in the supply chain space, doing a track and trace better, being able to track your chain of custody of goods through your materials. So, this isn't just about things that we can do that improve revenue. We actually can think about this as really improving life for all of us and doing some great things in the world just by doing the jobs that we were hired for. So I always think that that's a pretty cool thing. So again, I told you I'm a sourcing person, so I really couldn't let you go until I talk about okay, I have some vague idea of what Christine told me that this was. How would I actually buy this thing? So let's just start with some basics. There are code bases, right? Ethereum and Hyperledger are the two biggest ones, but there are others. They're open source, and there are also lots of other open source code bases built on top of both of those. You should research those, and you should figure out which one of them has the right kind of architecture and the right kinds of consensus and things that would work for you. There are a lot of consultants joining in the space. Who's got what, who's got the kinds of use cases that you're interested in, who's got kind of the same level of risk tolerance that you do. Are they talking to you about just kind of improving stuff you're already doing, or are they really talking about changing the world, and where are you on that spectrum? The software vendors, right? So there's open source code base, which is free, but maybe you just want to use blockchain, you don't want to build it yourself, and there are software vendors who can do this. You heard about Everledger, there's Ripple for cross-border payments, there's a whole set of vendors in the identity management space that we know of who are doing things like this. Consensus protocols, do you need 51% of the nodes to say yes before the transaction goes through? Is there some other way to do that? Again, I won't go into the proof of work and proof of stake and things like that, but those are actually things that you'd have to think about if you wanted to do something like this. So after you do your research, decide how radical you're willing to be. Again, are you trying to change the world, or are you trying to improve your profit margin a little bit, right? I mean, those are the kinds of things that as you start a proof of concept, you really want to think about in advance. There aren't a lot of blockchain experts, right? Most of the software companies that I talk to say they don't even try to hire software developers with blockchain expertise. They just hire really good developers and let them learn blockchain together, because there just aren't that many. And if you're waiting for the blockchain expert, you're going to be waiting a few more years. So what you're really looking for if you work with consultants is their process for bringing people on board and training people in blockchain, right? Because that's a much easier and simpler thing to get a hold of. And then make sure to cost out the entire blockchain. Labor is expensive because there aren't that many experts. We just talked about that. If you use the open source code base, that's free. Private vendors obviously have different licensing models. Compute power. So we were talking about consensus algorithms. A Bitcoin transaction takes the same amount of power as an individual's house for a week. And the entire Bitcoin network uses the same amount of power as the country of Norway. So depending on how you can create consensus algorithms that don't use as much power, and there are trade-offs for that. But I think we've all kind of come into the Moore's Law idea and that compute power is cheap. Compute power is not that cheap in the blockchain world, so you have to kind of think about that, right? And then there's infrastructure. You can put your node on a cloud. You might not want to do that. How many nodes are you running yourself? How many nodes are other people running? How much data is in your ledger, right? I mean, there are a lot of things around the infrastructure you have to think about too. So I want you to make sure to think about those things. And then spend time up front with the consultants, with the software vendors, other blockchain experimenters, people who are looking at this, and talk to them about all the stuff that could go wrong. There's a professor at Cornell whose name I won't tell you because I can't pronounce it, but he's very well known. I'm sorry, Amir. But there are a lot of things that we know can go wrong with blockchains, but we can think about them in advance and we can think about ways to mitigate them, right? But some of the known issues are it doesn't scale particularly well depending on the types of transactions that you're going to do. Like if you're going to do credit card transactions, there are so many of those that a blockchain would not be fast enough to do that, right? Land registry, ID certifications, those don't happen at the same pace, so those can happen in a reasonable time frame without the scaling issues. Think about interoperability and data porting. How is all this stuff going to get onto the blockchain? And how do I get it off, right, if I'm going to share it with somebody? Security of the interaction points. So you may have heard that a blockchain itself is unhackable. Again, barring quantum computing, that's actually true. But there are lots of ways that you can do an account takeover and take somebody's wallet. You can pretend to be somebody else to get into the system to then use their digital identity, right? So there are lots of interaction points you have to think about the security for. And then the user experience. Most of the things that I'm talking about are all back-end things, right? So how is your user or your customer or your trading partner going to interact with your system? And what does that user experience look like? So those are all things that you want to start thinking about, not just the consensus algorithm. So finally, we actually were just talking about Agile, but I'm talking about identities. One of my clients actually just said to me last week, he's like, there's no fail fast in identity. You can't get it wrong, right? So spend the time to get it right before you deploy, because you don't want to be the company that's out there that like, oh, somebody lost access to their social security number because it's locked and we can't get access, we can't unlock it given the way some of the blockchains work. So fail fast works in some situations, and particularly when we talk about transformation and innovation, it's a very popular thing to say. It's actually not what you want to do in blockchains. In blockchains, you want to get it right the first time for something like this. So with that, thank you. I think I am over time, so I don't know if I have time for any questions.
Sure.
Any question that can be answered in less than 20 minutes, how about that?
With the implementation of blockchain, the computational overhead for computing and refactoring the blocks is still relatively high. I know that's a backup in Bitcoin at this point in performing transactions. Mm-hmm. Moving forward, are there newer technologies other than just more processing speed, using additional power to now to start to address the additional overhead that's going to come with managing identity inside blockchain?
Mm-hmm. Sure. So is the question, is there a way to bring down the cost of the compute power?
Yeah.
So the thing that drives the compute power the most is the consensus that you're using. So are you using proof of work, which takes a lot of compute power? There are things called zero knowledge proof that don't take a lot of compute power for the miner, the original person a miner is the person who gets the right to say yes or no by kind of working on this computational problem. In proof of work, it's a cryptographic equation. There are other proofs that you can use. So if you did a zero proof model, then you could take that down. And also it depends on the number of nodes that you're running and whether every node is a voting node. So in Bitcoin, 51% of every node, right, all of the nodes together, 51% of them have to say yes for the transaction to go through. You could do a model, for example, say with identity, is that as long as the US government validates that identity, you only need that node to say yes. You don't need all the other nodes to say yes. So you could take down your compute power by doing it that way. Some of those models are less secure because, of course, the whole point of doing the consensus algorithm in the first place is that it's less, you would be better operating the system as a good actor instead of a bad actor because it would just be too complicated to try and hack into the system, right, and to mitigate a bad result. So you have to be careful when you pick. You can change your consensus algorithm to lower your compute power, but you don't want to do it in a way that increases the risk that somebody could take over enough nodes to change the data.
Hi.
Hi, Joe.
You made the case that blockchain is very cool. You made the case that digital identity would be helpful, but what is the case that says that it wouldn't be just as easy to have, say, a national government database using 50-year-old relational database technology to do a lookup? Like, why can't I just do that for most basic identity reasons?
Yes, so it's a great question, right? Because that was what we were saying earlier. There are a lot of things, there are a lot of problems that don't need a blockchain, right? Because the blockchain is less effective than maybe some other methods. But in the model that you're talking about, so again, the first thing you said was that it's centralized, right? A blockchain by definition is decentralized, right? So the reason that the Equifax hack was such a big deal is because everybody's data was all in one database, right? And it was not encrypted, and you make it into the database, and then there you go. And so for hacking reasons, you'd want to think about that. Also, the centralization, right? You want decentralized data. And it also doesn't solve the problem of self-sovereign identity, which is that we each have personal control over our data. So in that particular case, there are solutions for parts of identity that you could do in other ways. But particularly in this case, I think that blockchain allows us to do things, particularly around self-sovereign identity and consent to use our data, that aren't possible with other technologies.
And I'm always concerned about whether the decentralized sources and how many of those become bad actors at some time in the future, right? So if the data that the ledger is getting to create the identity is bad, then the identity itself is bad. Is there a lot of work about taking all of the various sources that sort of feed the ledger to create the identity to create or eliminate false positives and things along that line? Is that ongoing work? Is that still an issue? I just don't understand where that is.
Sure. So if we're talking about how the data get into the system, right? So the basis of this would be like, let's talk about social security numbers and passports, right? So the idea would be that that number gets entered in online and gets certified by the US government, right? That says, yes, Christine has the social security number in this passport, right? Maribel has a different set of numbers, and those are certified, and then those are encrypted. But then the only thing that the network has are the cryptographic keys. They don't have that data in their database. They have the key that says the government certified it. Now, if by some chance that data got entered incorrectly and my social security number is wrong, the way that blockchains work is I can't just go back and erase the data and put in a right number, because that causes everything else to be wrong, right? Because it recognizes that the hash has now changed and it changes all the end results. So what we'd have to do is have a system in place to correct errors, but it would be a new transaction, right? So if, in year one, something, happened that the deed to your house got registered incorrectly, then, what would happen is you'd do another transaction to change to the correct data. You wouldn't go back and try to fix the old data.
I'm thinking less about government-certified organizations and more like the persona that may be generated by a Facebook as an entity, for example, or maybe I have 4 or 5 bank relationships. Maybe some are certified, maybe some they're not. maybe it's an Eastern European that is pretending to be a bank and a certified source. Are those issues that people are thinking about? Are they issues?
Yeah. So I think there are issues that people are thinking about. I don't think those kinds of issues are specific to blockchain itself in the sense that, right, I mean, if you're creating a fake bank account, right, I mean, I think that that's possible. I do think that in terms of bad actors, blockchains are better at picking up when people are doing transactions that are not right, right? So when I was talking about the nodes, if you wanted to, do a transaction using an identity that, was falsified, right, like a fake ID of some kind, then all the other nodes would come back and say that data doesn't match something that we already have in the system, so that transaction doesn't go through. It becomes an orphan transaction. And so it never gets actually put on the block, right? So if the nodes decide that a transaction shouldn't happen, it doesn't get put into a block. It gets kind of shunted off to the side. And so from a security perspective, you actually can still do things like do evaluations of how many people have tried to do transactions that aren't valid, right? Because you still have the orphan transaction. It's just not attached to the block. So the bad transactions don't actually ever get put into the blockchain, or as long as the system recognizes them as a bad transaction, it wouldn't go in.
Okay, this
I'm going to let Phil decide if I can take that question.
last question.
So who owns the data, the actual data in the block? Because it seems like to me we're spreading the problem around. Even if it's distributed in a ledger, someone needs to control, and everybody has to buy in that we're doing this, like the government has to be able to say, okay, I'm going to put your identity in the blockchain. Then everybody else has to say, oh, yeah, I'm Facebook, I put your identity in the blockchain, right? And those all have to match, and that access has to be controlled from each of those points. So it seems like to me if you do centralization, you control it that way, but now we just distributed the access to everybody.
So yes, in some forms of it, that's true, right? So there are different ways that you can create a blockchain and different ways that you can decide what goes on-chain, right, and what's off-chain. So for example, in identity, what could be part of the distributed ledger is just the certifications, right? So you don't have my social security number, you just have a cryptographic key that's the encrypted yes, no of does Christine have a valid social security number. So what each member of each node or each copy of the distributed ledger has may not be everybody's data. Because to your point, right, I mean, if we're just recreating a database of social security numbers and now everybody's got one, right, then it wouldn't be worthwhile. So there are some blockchains, like for example in Bitcoin, when people say it's private, it's not private, it's anonymous. So you can see any transaction that's ever happened in Bitcoin if you wanted to. It just happens that you don't know who owns the particular wallets involved, right, because they're anonymous. In this model, it would be more of a permissioned network, so you'd have to decide which networks you'd want to be part of. They would know like which entities are interacting with each other, but the data itself would still be encrypted. So it's the difference between a self-governed model, or what they call permissionless, where you can just join just because you feel like it, and a permissioned model where you'd have to be known to the other participants to be part of that network.
Christine, thank you so very much.
Thanks.